Okay, now I will start with one of the questions in tutorial 3. This question was actually raised by one of your classmates. So that is question 12, all right? Okay, how come I cannot open with something not right? Never mind. I use this annotation. I think I can write like this, right? Okay. So for question 12, solve the equation 7 cos squared x plus sine squared x equals to 11.5, giving your answers in logarithmic form. Now this one is an all past year question, yeah. I cannot open with how come? Last time can, now cannot. Okay, never mind. So you see for this part here, giving your answers in logarithmic form. Now this one is an old past year questions, yeah. Now the question here say giving your answers in logarithmic form, right? Now, for the new this is the old past year question. I will show you how I get the plus minus ln 2 later, all right? But for the new syllabus, I have checked with Mr. Yong, who is the subject leader of further maths. This question 12 here, he said, for the new syllabus, when they want to ask, right, they will actually impose a restricted domain for this question. That means the question will be changed to solve the equation 7 cos squared x plus sine squared x equal to 11.5, giving your answer. Now, in this case, for the new syllabus, you will only have one answer in logarithmic form. Then they will add in the domain for you. All right. The domain here is x must be more than or equal to 1. That is the domain given. All right. So therefore, for this question 12, right, for the new syllabus, you will only have one answer. So the answer is ln 2. All right. So I will write down this one. Wait. Right. So once I cancel, then you cannot see already. Yeah. Okay, never mind. I just put it here. So for tutorial 3, question 12, the question will be, what is the question again? 7 cos squared, 7 cos x plus sine squared x, and this is equal to 11.5, and then you add in this yourself, you add in the domain, add in. Okay, for x is larger than or equal to 1, so you add in this domain, right? This is for the new syllabus. Then later I will show you the old syllabus, how they get the 2 answers there. All right. So to solve this question, I think no issue already. So majority should be able to solve. So you should be able to solve this 7 cos squared plus sine squared equals to, now 11.5 is actually 23 divided by 2. I put it in the fraction form. All right. So you have 2 ways of solving this one. Number 1, you use identity. So what is the identity that you can use? Cos squared equals to sine squared plus 1. The second way of solving this one is by using the identity sine squared is equal to cos squared minus 1. So up to you. You want to use sine squared plus 1 or cos squared minus 1 also can, right? So in this case, you will only have one answer because of the restricted domain here. All right. So the final answer, so correct answer, you will get later. You solve, you see how I solve later. Answer is ln 2 only. Right. This one is for the new syllabus. That means the syllabus that you are currently studying. Now for the old syllabus, right, why do you have 2 answers for all syllabus? So why 2 answers? Is the recording affected? So I continue, yeah? Okay. So in that case, we look at the old syllabus, why there are two answers in this case, okay? Now, first of all, I want to derive the formula, the logarithmic form for cos inverse. So what happened is, I let y be cos inverse for x, all right? Now, you have to remember for the cos x, all right, I am deriving this one using the inverse function. Let's say I start with let y be cos x. So most of you know cos x is not a one-to-one function, correct? So therefore, in order to make it one-to-one, there are two possible domains you can consider. The first one is you consider x is greater than or equal to 0. So the corresponding range would be y is greater than or equals to 1. That is the first one. Now the second one is when x is less than or equal to 0. So therefore you have y less than, y is still greater than or equals to 1 with reference to the graph, correct? What I mean here is the red region would mean this part lah. Okay? Now the blue region refers to the second one. So the second one is here. All right. So the blue region refers to this one in the blue box. So there are two different one-to-one function in this case. So you know that the minimum value here is 1. Right. Your syllabus is actually considering this one. This is in the syllabus. In syllabus. This one is out of syllabus. Right? But it's in the old syllabus. That's why in the old syllabus, they consider two signs later. All right, I show you. Right. Let's say now we follow the syllabus first. So what happened is you let, so I'm doing the red color for the one in the syllabus. Yeah. So you have y equals to cos x. Then you have x is greater than or equal to 0. Then you have y is greater than or equals to 1. So now what happened is you interchange the x and y, and then you make y the subject. Interchange x and y. So you make y the subject. So in other words, you would have x is equal to cos y. Therefore, your x greater than or equal to 0 becomes y greater than or equal to 0. And the y change to x greater than or equals to 1. You see or not? So therefore, we have x equals to cos means half. So you have 2x.
Wait, is it blank? Oh, wait. It's gone again.
Again.
I was like, was it
You
fading
have to
for
keep
you
it
guys?
many times, Hawari. This is your job now.
Okay, okay.
Don't know why. I think
It's back now.
mine today is not very good.
Well, it's
Okay,
still black for
can
me
I
though.
proceed?
Okay,
Okay.
okay, okay.
So we have okay. Just now you
Is it
said no
laggy
way.
though? Is it laggy for you guys?
Can I proceed?
Yes, sir.
Okay. Right. So we have 2x equals to e to the power of y plus e to the power of negative b.
Eh? Faded again. I mean, I can see an exclamation mark.
Sir, I can't hear you.
How is it
Plus
time break? What does that
1
mean?
equals to 0. Using the quadratic formula, quadratic formula would tell you that e power y is equal to, so you have negative b, so therefore you have 2x plus minus square root of the answer, b squared. So you have 4x squared minus 4 times a times c divided by 2 times 1. So in this case, you have 2x plus minus square root of, so factorize the 4.
Oh, GG lah. It's okay lah. If whatever he writes down, right, it'll be useful anyway. No, what do you mean sem break is right now? It's
Supposed to be
the break after mocks. It's not sem break.
sport break.
Yeah, but we don't even have
Hello?
mocks.
Is it freezing for you guys?
Sir,
Hello, Mr. Lee.
I think he got disconnected.
Oh, okay. There's no break if we didn't have mocks. You moron. What do you mean? Just because somebody asked for a sem break doesn't mean we need to actually follow it, right? Because we didn't even have mocks. Okay, it's back. I mean, we all could see that there was an exclamation mark, right? Yeah, next to it, the Wi-Fi symbol there.
Okay. Jason, anything? Okay.
Yes, sir.
Can I proceed?
Yes.
sir. Sir,
Oh no. Uh-oh.
Hello, sir. Mr. Lee. Hello.
sir.
Lee?
Wow. Oh, this is really bad. If there was any class that I don't want to miss, it's probably his class.
Internet is not building. Wow.
Can I proceed?
How many times should he ask can I proceed and then
Okay, so you can proceed now.
Okay.
Just now you disconnect again.
Okay. Okay.
Every single trick
So
is just gonna start with, can
we
proceed?
have
Can I proceed?
2x plus minus 4 times x squared minus 1. So this is divided by 2. So in other words, you will get 2x plus minus 2 times square root of x squared minus 1 divided by 2. So in this case, yeah, you will get the answer. So you can cancel out the 2. So you cancel out the 2, cancel out the 2, cancel out the 2. So in this case, you will get the expressions x plus minus square root of x squared minus 1. Now, when I throw away the exponent, I don't want the exponent, so you have to ln both sides. So when you ln both sides, you will get y is equal to ln x plus minus the result. Okay, x plus minus the square root of x squared minus 1. Now, what happened is, you see inside here, there's this plus minus. Okay, there's this plus minus. I'm going to remove it. So how do I remove it? So you can rewrite this one in two other forms. So you can write this as ln and then x plus square root of x squared minus 1. That is the first form. Or the other one is ln of x minus square root of x squared minus 1. However, for those who learn IGCSE, okay, the operations involving the surd, yeah, so you have heard of this term known as conjugate surd. I'm going to do something on this cyan box. Okay, I'm going to do something on this cyan box. So this is how the modification goes, all right? So you look at the orange color. Now this one, I can rewrite it as x minus square root of x squared minus 1. Now I multiply up and down by the conjugate of this one, x minus square root of x squared minus 1. So when you multiply by the conjugate, right, you get something like this. The green color is the conjugate, x plus square root of x squared minus 1 in the bracket. And this is what you call the conjugate surd. SPM, I think you didn't learn this one, conjugate surd, but you all learn the conjugate complex number, all right? So similar concept. You just change the sign to positive. This one is negative. So when you multiply up and down by the conjugate surd, so that means you will have to multiply by x plus square root of x squared minus 1 up and down. So you continue to operate. So you will see that this is equal to x squared minus bracket square root of x squared minus 1 in the bracket squared divided by x plus square root of x squared minus 1. Okay, so continue. You expand the square root and the square. So you can cancel out the square root and the square. Becomes x squared minus x squared minus 1 divided by x plus square root of x squared minus 1. So if you simplify further, right, you get the answer 1 over x plus square root of x squared minus 1. Now, what happened to the cyan box? Therefore, I can continue with the red color. The red color solution, I continue here. So you would see that y can be expressed in two forms. So the first form is ln x plus square root of x squared minus 1. Then the second form can now be re-expressed as ln of 1 over x plus square root of x squared minus 1. Correct? Therefore, y is equal to, now you have now plus minus ln of x plus square root of x squared minus 1. You have this form. So you have plus minus. Which one are you supposed to take? So you look at the domain, you look at the domain, right? So let's look at the first domain, the red color domain that we have just now. The red color domain is x greater than or equals to 0, y greater than or equals to 1. Therefore, you have to take the positive value. So for the red domain, so you have like that. This one, minimum value is 1. After you take the reflection in the line, then it becomes like that. So it becomes this way, 1 reflection, all right? So the 1 is reflected to this x-axis here. This is the graph for y equals to cos inverse of x. For the domain x greater than or equals to 1, and the range is y greater than or equal to 0. Therefore, you have y equals to ln x plus square root of x squared minus 1. Okay, this is how you get the formula, the logarithmic form given in MF19. This one is in MF19. Okay, now for the blue color just now, for the blue color, we have this curve, right? So for the blue color, which is not in your syllabus, for x less than or equals to 0, y greater than or equals to 1. So for the blue color, it goes this way. So for the graph, this side, you have like that, right? The minimum value is 1. Now you reflect. So after you reflect in the line, it becomes the graph like that, going down. Okay, So this is the domain x is still greater than or equals to 1, but your y is less than or equal to 0 in that case. Okay? Both also x greater than or equals to 1. I think I have to specify something like y is greater than or equals to 0. Your cos inverse x must be greater than or equal to 0. That means the hold on, let me check. Okay, never mind. I will send you later. I will check again later the domain that I should impose in this case. So y is less than or equals to 0. Therefore, you have the other solution. Y equals to negative ln x plus square root of x squared minus 1. So this one is for this domain. X greater than or equals to 1, and the range is y less than or equals to 0. Okay, so therefore in the question number 12 that one of your friends asked the other day, you will only have one answer in this case, question 12. But the domain is not x greater than or equals to 1. I think the domain should be, I will check again later how to modify the question. No matter what, you have only one answer for the new syllabus. Do you get me? Any problem?
No, sir. Thank you.
No, sir.
Okay, so therefore for that question, you will only have one answer for this question. Okay, I think I will see how I change the question. It cannot be x more than or equals to 1 already in this case. I will check again later. All right, so I think this one not relevant. I will check again and then let you know later in the group. All right, so this is the clarification for question number 12 of tutorial 3. Okay, so this is how you solve it. All right, now I didn't solve the whole thing. I didn't solve the whole thing here, so I expect you to go and do it yourself. All right, DIY. So you have two ways of solving this. By using the first identity, you change the cos squared to sine squared plus 1, or you change the sine squared to cos squared minus 1. Up to you. All right, so now we proceed with the lecture that I want to talk about today. I hope all of you have already downloaded the latest formula list. Sorry, not formula list, notes. I don't know why I cannot use the write on PDF now. Okay, never mind. So all of you should be able to see that I give you 4 columns. So the first 2 columns are in the formula list MF19. The last 2 columns are actually the general result, the chain rule that I told you last week. Is that okay? So today I will continue. I will continue with obtaining expression for d2y dx2 in the case where the relation between y and x defined implicitly. All right, this is actually implicit differentiation. How do we find the second derivative when the functions or the equations are defined implicitly? All right, now before I move on to this section, may I know, have I discussed with you all questions from number 1 to number 6?
That he gave us.
Number 7
The new one.
is actually the second derivative already.
I think he shared it to us. Wait,
Have
wait.
I discussed with you 1 up to number 6?
But I don't see the table though.
I think number 6, I have not talked about it, right? Cosec inverse. Have I?
Not yet, sir.
Kevin, all right. So I will talk about number 6 first. So question number 6.
Yeah, in my notes, the Maclaurin's theorem is the last one. And then
Okay, number 6.
state it lah.
It is given that y is equal to cosec inverse x. Show that for x greater than 0, dy dx is equal to negative 1 over x square root of x squared plus 1. And write down an expression for dy dx in terms of x for x less than 0.
是只有中国假期耶。
Yes, Yi-Heng? I share this file first. You all prefer me to share as image or PDF? Image or PDF?
Both are fine, lah, sir.
So which one would save more space in your phone? I don't know.
I don't know, maybe PDF will do.
PDF.
Yeah, PDF is better.
Okay, then I send PDF. Okay, so now we will move on to the class today.
Thank you, sir.
So I will talk about lecture 4 differentiation. I think I have to start with question number 6 first. So question number 6. You are given y equals to cosec inverse of x. So you don't know how to differentiate this one. So therefore we use the method like what I showed you earlier. We put this as cosec y equals to x. All right. So probably you can change this one to 1 over sine y equals to x. Or you can say sine y is equal to 1 over x, right? You see the final answer, you have the form 1 over x and then square root x squared plus 1. So most likely you will have this form 1 over x. Okay, so you differentiate both sides. So this one means x to the power of negative 1. Yeah? So you differentiate both sides with respect to x. So I have cos y. You differentiate sine y as usual, but remember you have an additional term, dy dx. And this is equal to negative x to the power of negative 2, right? So you have dy dx equals to negative. So you have 1 over. Then you have x squared, then multiplied by cos y at the bottom. So using the identity for cos y, so you have negative 1 over, so x squared. So this will give you square root of, now cos y, using identity, this means 1 plus sine, 1 plus sine squared y. So you change the sine squared y to x. So therefore you have negative 1 over x squared. Then you have square root of 1 plus. Now sine y is actually 1 over x. So sine squared y means 1 over x squared. So now you can simplify further. Negative 1 over. So the x squared you copy. Now this one becomes square root of x squared plus 1 over x squared. Simplify further, you get negative 1 over x squared times square root of x squared plus 1 divided by x. Because square root of x squared is actually x in this case, therefore you cancel out the x, you cancel out this x and the square here. So you obtain the form. So therefore the answer is negative 1 over x times square root of x squared plus 1. Done.
Teacher,
Yes?
teacher. From the sine y equal to 1 over x, can I just move the sine to 1 over x, then become y equal to sine inverse 1 over x, then just use the formula in data booklet to...
Can.
Can I?
Is that faster? Probably that one is faster.
I don't think I did.
Yeah, it's
I don't
faster,
think
I
Shine.
think.
did.
Then you can continue with that, no problem. Okay, so that means you have
Function.
that means you change what Yi-Heng was saying is you change this one to y equals to sine
Did 7 already,
inverse.
not not
1
17,
over x, right?
Yeah.
up
Okay.
until like 20.
So you use this form. Sine inverse 1 over x. Then after that, you use the standard formula. Am I right?
7 now.
So alternative, you have y equals to sine inverse 1 over x. Then you use the formula. dy dx is equal to. So you have the formula, which one? Here. So you use the table that I gave you. The table that I gave you, I think this one. So you have sine inverse x is 1 over square root of 1 plus x squared. So you replace the x with f of x. So you remember to differentiate the f of x, Okay. In other words, you are using this one. This one. I cannot write. I want to open with, but I'm not allowed to do so. Right? So this is the formula. The middle one. This one. Middle one. Okay. 1 over square root of 1 plus fx squared. Then you differentiate the f of x. All right. So you use this formula for the sine inverse fx formula. So you should be able to get the answer. So this one, do it as exercise. Do it yourself. So you must be able to get back this one. Then the second part, they ask you to write down an expression for dy dx in terms of x when x is less than 0. So when x is less than 0, yeah. Second part, when x is less than 0, so they ask you to write down only. So the answer, dy dx, is actually equals to 1 over, okay, you have x square root of x squared plus 1. So what you do is you replace x with negative x. Okay, therefore the result is 1 over x times square root of x squared plus 1. Okay, now for those of you who are interested to look at the graph, there's most graphing calculator. So you can look at the graph. You can look at the gradient. The gradient is always negative. So this one is, the formula is y equals to cos. Cos of x. Cosec inverse. Sorry, it's not a cos. Cosec inverse. Cosec inverse means what? Sorry. Cosec inverse means I have to put